This is another important issue, like transmission. Transmission means power will be in one place, but action will be in some different place. Like when we ride our bicycle, we pull on the middle, but the wheel is spinning on the back. So we are using chain for transmitting the power on back. Okay? So chain, timing belt, these are the things that can be used for transmitting the power. Okay? This is another thing for transmission. Gear system. Okay, gear is another very, very important for robotics guys. Okay, who work with robotics, they need to understand the gear. Number 1, gear can reduce the speed. Number 2, gear can change the direction, like from this direction to that direction. It can change the direction. Number 3, it can reduce, it can increase the speed. Okay. Number 4, it can even, change the form, like rotation form to linear form or linear form to rotational form. So gear is very, very important for robotics. Okay. For your information, when we use gear, the speed and the power is inversely proportional. Like if we use spur gear, if it reduce the speed, then it will increase the power. Even in the worm gear, in our car window or for the cleaning the wiper motor, they really used worm gear. Okay, it decreased the speed 1:80. That means it decreased the speed 80 times, but surprisingly it's increasing the power 80 times, minus few mechanical loss. Okay, even the mechanical loss also can be reduced by using lubricant. Okay, so gear is another very, very important issues of robotics. Okay. This is a link mechanism. Link mechanism means, by using one power, it's linking with a number of things. So by using one movement, it's doing 2-3 jobs. Okay, so keep in your mind how we can do it. Like in our first significant robot, like in Chandrabot, one was we were just putting up the basket, putting up, and when it was putting up, it's also going forward. So by using just one motor action, one power, it's also going up and it's also going forward. Okay, so that kind of things are called link mechanism. Now we would like to discuss about few motors, okay? Basic motors. In robotics, in embedded systems or in digital systems or in hardware systems, we really use mainly 3 kinds of motors. One is DC motor, another one is servo motor, another one is stepper motor. Okay? Let us discuss about a stepper motor. Stepper motor means step-by-step motor. Like if you will give power, it will take one step. Like it was here, you will give power, it will take one step. Okay? Again, power up, second step. Again, power up, third step. So actually, a motor have 4 connections. When you will give power on this connection, then it will take this movement. If you will give this connection here, it will take this movement. If you will give connection here, it will take this movement. If you will give connection here, it will take this movement. And then again come here. Okay, this is called stepper motor. The advantage is the rotation you want, the degree you want, it can be pre-programmed. Like if you want a 90-degree rotation, so you can see here, we need 5 steps. If you want 180-degree rotation, we need 10 steps. 360, 20 steps. If you want 5 rotation, 100 steps. So it can be pre-programmed. Okay. Before some days back, most of the printers, even the floppy disk drive, even some CD-ROM also was building by using this kind of a stepper motor. But the problem is stepper motor become heavy, because since we have to use 4 coils for 4 steps, usually 4 steps. So it become, number one become 4 coils become means complex, structure become complex, become expensive, become heavy weight, okay, difficult to make the program. Okay, so these are the problems with stepper motor. Okay, mainly expensive and it become heavy weight. Okay, so now in robotics we move from stepper motor to DC motor. DC motor is very simple, very cheap. You know, even 50 taka, by using 50 taka you can get a DC motor in Bangladeshi market. Okay, and the technology is very simple. There are 2 fixed magnet, North Pole, South Pole, and you are having a coil. Okay, and there are 2 brushes on your foot. So when this leg is on this brush, positive brush, and this leg is on negative brush, the coil is built in such a way so that my right arm, my right side will become North Pole and left side will become South Pole. But as I told you, there are fixed magnet on right side is North Pole and the fixed magnet on left side is South Pole. So that one is North Pole and my body also become North. And in the same way, in this side, that is a fixed magnet with South Pole and my body is also South. What is going to happen? They are going to push me. Okay, so I will spin and you see my leg will change the brushes. So now my right leg is on left minus brush and left leg is on plus brush. So when my configuration will be like this, then again this body will become North and this body will become South. Again I'll take a spin. That is the way, very simple technique. Okay, so that's why this becomes so cheap, easy to control, easy to drive. Okay, so that's why DC motor become very cheap, become very popular. Okay, in robotics we use a number of purposes we use DC motor, but there are 2 very, very important issues involved in DC motor. Number 1 is speed. Okay, the speed is too high, it cannot be controlled very easily. Okay, and number 2 is, so number 1 is speed. Sometimes we need to reduce the speed, sometimes we need to enhance the speed, like for quadcopter we need to enhance the speed. Okay, and the second thing is the controlling. Okay, like we want to take 3 spin. In DC motor you cannot do it. With the load, maybe with the same power, it will take 5 spin, but without load, it will take 7 spin. So, to overcome this thing, we are using, one is gearbox, and third thing is the power. Usually the DC motor become very, very low power DC motor. Okay, you can stop by using your fingers. Okay, so number 1 is speed, number 2 is as I told you, power, and number 3 is controllability. Okay, so these 3 things can be handled. Number 1 by using gearbox. If we use a gearbox, if we reduce the speed, power enhance, or if we will use opposite gearbox, the speed will enhance but the power will become low. Okay, so one is gearbox and another one is feedback. Like we can use some feedback system with the motor shaft so that we can read how many spins it have taken. So if we can take the if you can sense the rotation or every movement from each point, we can DC motor can be used as a stepper motor. Okay, so yes, we are using feedback system with a DC motor for getting the input from the motor, how far it or how many rotation it have taken or how many degree it had rotated. Okay, so number one is gearbox, number two is feedback system. By using these two things, DC motor can be used just like it can be replaced. Okay, so by using these two things, one is gearbox, another one is feedback system, stepper motor can be replaced. In servo motor, actually these two things are embedded. If you will see inside the servo motor, you will see there is a gearbox, and if you will dismantle it, you will see there is a potentiometer. Okay, it's taking the feedback, like how many spin it have taken. Okay, so by taking that input, it has a control system inside the motor. Okay, it's giving you the degree. So again, so servo motor, I didn't explain about servo motor. Servo motor is a closed loop motor. Like if you will say 90-degree servo motor, that means it will take 90-degree this way and minus 90-degree, plus 90-degree, 0, 90, 0, closed loop. It can go from this position to this position, this position to this position. Okay, if we say 180-degree servo motor, it can take 180-degree. Okay, if we say 360-degree, doesn't mean it is spinning. No. Okay, it's coming here and going back, coming here, going back. Okay, so that is called a servo motor. Very, very popular in robotics. Okay, yeah, so servo motor is very, very useful. Okay, students are using the servo motor for making their demo project. Okay, demo system, they are using randomly. Okay, these are very cheap, from 200 taka to 2000 taka. Okay, so this is very, very popular. So I discussed about three kinds of motor. One is DC motor, stepper motor, and servo motor.